Thank
Okay,
you.
thank you. Hello, my name is Marta Waldmann. I represent Łukasiewicz Poznań Institute of Technology, and we are partner of SARIL project. And today, together with Kelly Pitera from Sintef, we will present you some of our tools that we are developing in SARIL. But first, I will tell some words about the project. Project SARIL is project that focusing on logistics network and mostly on tackling with the disruptions. So the topic of our meeting today is very much connected with the topic of our project. Here in Saril, we want to improve decision making processes in transport and logistics systems. The systems that are facing disruptions, and we also want to combine this resilience and sustainability aspects when we will manage the disruptions in our life and in our logistics process. Together with our partners from 9 countries, we are developing the solutions that are supporting logistics networks, support the decision system, and develop the concepts for resilient and sustainable logistics during the disruptions. In this project, we are working on 3 levels of scenarios and the different disruptions. We have regional, national, and European scenario. For each scenario, we are focusing on different disruptions and today we will be talking about mostly about the tools which are connected to European scenario, in which we are focusing on pandemic and war and some implications that comes from this main let's say group of disruptions. What we are simulating in this scenario is that we are focusing on containerized cargo, which is delivered from Far East to Northern Europe, both by sea and railroad. And in our tools, we want to, with the use of our tools, we want to simulate 2 main disruptions: the port closure and the closure of north path of New Silk Road. We are also focusing on the time of the cost and other time cost and use of sources, CO2 emissions, um, implication on the rerouting and the effect of the disruptions that happened on the logistics network. In this scenario, we have combination of 3 tools. One is disruption information interface, which is developed in Łukasiewicz PIT. The second energy module, which is developed in Sintef, and Kelly will be talking about it in a few minutes. And the third tool is Asteroid, the tool which is created by Fraunhofer EMI. And because we will not most focus about the Asteroid tool, I want to share some information about it, because it's also very important part of the solutions for European scenarios. So this Asteroid tool is a tool that supports strategic decision to optimize efficiency and sustainability in transport networks. It's dedicated for the stakeholders in transport sectors who need to develop resilient strategies. So both strategic planners in transport companies, but also some infrastructure planners and also public authorities. Asteroid enables us to simulate disruption, to simulate the future scenario, to simulate reroutings, and also to base on some information that comes from other tools also on the disruptions that are coming from, for example, disruption information service interface that we are developing in Łukasiewicz PIT. And now I will tell something about our tool, the tool that my colleagues from Łukasiewicz PIT are developing, and how it works. The disruption information interface, it's a tool that connects different tools from the SARIL project, and the tools that are working with the disruptions, for example, forest fire maps, some producing some flooding maps, or delivers information about road capacity. But also in disruption information interface, we also use the external sources. So we also use some web pages, some newsletters, some subscriptions that logistics people that are working in logistics, and they are people who works as operational staff is working. Why we decided to build this tool is we wanted to create some access point, maybe one, let's say, single window where people from logistics may find information about the variety of disruptions that may affect their logistics corridor. Then when we gather this information in disruption information interface, we also distribute this information as map or as some interfaces or some connections by application. We distribute it to other tools. In our project, it is mostly the Fraunhofer's tool, so it's Asteroid. For whom we develop disruption information interface, it's mostly for the stakeholders that want to avoid disruptive events on their road. Mostly we develop it for operational planners, for people who are working with living logistics every day, but also it may support strategic decisions. As I told before, we gathering disruptive events from different data sources. We can collect information important for the stakeholders. If stakeholder wants this tool to search on some important web page or some branch magazine that is important for them, this tool also may do this. What is also important here, that this tool is using large language models to predict disruptive events attributes and to discover some different disruptive events data. Short about the construction of this tool. The first thing very important is a module with data collecting. This module primarily collects data generated by the project partners, but also data from outside SARIL ecosystem. And we collect here and receive data from local authorities responsible for reporting traffic disruptions. At this moment, we are gathering information from Czech Republic, Germany, France, and Poland. We are waiting for data from Austria and Italy. We in this tool we also monitor websites related to transport news, where you can find information about the disruptions. We can also collect this data and structure it and to enable its further use. But it often happens that information about a disruption that reaches us directly, bypassing other media. So the person acting as application administrator has also the ability to manage information, this information in the context of our tool. They can add it, update it, or transfer the disruption into the tool. A very important module is attributes prediction. And to address one of the main problems of the existence of traffic disruptions, like predicting how long a given disruption will last, this prediction module was created. A big problem is the information that reaches us that is not a disruption. And thanks to the support of this large language models and other statistical methods, my colleagues extract only that valuable from in this tool. They extract only the valuable information from the system's point of the view from the obtained data. In this way, this tool makes the life of data administrator much easier. And the most also very important module is data sharing. So the final let's say cycle of the information. The last but most important is sharing this data. In example, the information model, its main function is to return information about disruption or hazard for a given section on a map. So we can this tool can show where on the map, where on the logistic system the disruptions occurs, and what are the attributes of this disruption. So where, when it happened, and what is the predicted time of this disruption, and how long it will take to manage this disruption on the logistics network. Why this tool is better than existing solutions, and why anyone may or should use it. So the main point was when we created this tool and we discussed with our stakeholders, the stakeholders of the project, but also external stakeholders by some surveys. The main point is that there is one access point for the information about the disruption. So now the people in logistics are looking for the disruption. There is no one source when all the disruptions may be collected. And what is also important thing here is the searching this tool is searching for the disruptions in the real time. It predicts the time of the disruptions and return the information about the hazards on a map or by the connection with the API to the local tools of the logistics provider or on the users.